Okay, today we're going to talk about differential equations. So first, to warm up, we're trying to find a general solution. So in order to find the general solution, I need to take the integral of both sides. So the integral of dy dx is going to give me y, and the integral of e to the 2x dx gives me 1/2 e to the 2x. And then don't forget the plus c. And so if it's in a general solution, we have to have the y here. And the reason we call it a general solution is because it's a family of functions where we have the c. The c basically gives us the family that looks like this. And we discussed the family in, I believe it's H11E. Okay, this one here, same thing, we do to the derivative on both sides. The antiderivative of dy dx is y. The antiderivative of this, okay, we have to use u substitution. So I need to let u equal x squared plus 1. And then, so then I get we're going to say that the derivative of u is du, and the derivative of that is going to be the derivative of x squared plus 1 is going to be equal to 2x. And then I multiply, this is du dx. And then I multiply dx on both sides, so then I have du because this is equal to u, right? Du is equal to 2x dx, and so I've got the integral of 2x over x squared plus 1 dx. So I'm going to rewrite this as the integral of 1 over u dx du 2x dx, and then I'm substituting that with du. So I have the integral of 1 over u du, which is equal to the natural log of u plus c. And then we can't just leave it like that. We got to substitute the x squared plus 1 back in place for u. So we get y equals natural log of x squared plus 1 plus c. Okay. And the reason we do the absolute value is because this always needs to be positive. You can't do a natural log of anything negative. But in this case, we don't really need to have the absolute value, because whenever you square something, it will always be positive. And because it's plus 1, it's always going to be positive. So the absolute value is not necessary in this example. Okay, let's look at the next example here. Find the particular solution for this given this point. So what we just found here was the general solution. And we have the general solution. It's going to have the plus c. Okay, so now we're going to find the particular solution. So the first thing we have to do is find the general solution. So I'm going to subtract 1 on both sides, and then have dy dx equals cosine x minus 1. And now I'm going to take the derivative, the integral of both sides. then we get y equals, and the derivative of cosine is sine x, and the derivative of -1 is negative x, and then we have to plus c. So this is our general solution. Okay, and now we're going to let x equals 0 and y equals 1/2. And we're going to plug that in and solve for c. Okay, so if x is 0 and y is 1/2, I end up with 1/2 equals sine 0 minus 0 plus c. And sine of 0 is 0, so I end up with 1/2 equals 0 minus 0, so c is going to be 1/2. So therefore, the particular solution is y equals sine x minus x plus 1/2. Okay. So okay, so we're talking about separable differential equations. So here we go. So basically what they're saying is if I have dy dx equals this, we can bring the g of y to one side, and we can bring the dx to the other. So then I end up with 1 over g of y dy equals f of x dx. And then we take the integral of both sides, just like we've got here. Okay. Revision Village explains example 1 and example 2 incredibly well. I really want you to watch their video on this for separable differential equations. But I'm just going to walk you through what I wrote after I did their thing. So first thing we do is we divided both sides by y to get the y's on one side and keep the x's on the other, and we multiply both sides by the dx. And then we took the integral of both sides, and the antiderivative of 1 over y gives me natural log of y. The antiderivative of 2x dx is x squared. And then we would put plus c on both sides, but there's no reason to have two different c's, so we just write 1c. And natural log is the same thing as log base e of y. And then to convert this to exponential form, I could say e to this power is equal to y. And the reason we convert it to exponential form is because we're trying to solve for y. And since y is here in the natural log, we have to convert it into exponential form. Okay, so now we've got y equals e to the x squared plus c. So that's the same thing as saying e to the x squared times e to the c. And one of the things your textbook likes to do, and other mathematicians, they like to call e to the c the just constant a. And so this is our general solution: y equals a e to this power. Okay. And once again, Revision Village explains this incredibly well. I'm just going to hit pause if you want to copy this down, but I really want you to see Revision Village's explanation. Now on example 22, Ms. Castro explains this one really well. You may want to hit pause if you want to just copy this down, but you really should see her example. Okay, I'm going to do example 7 here. Okay, so since this is separable, we want to bring the y to over here. So I'm going to have divide both sides by y and multiply both sides by dx. So if I multiply both sides by dx, I get that over here. If I divide both sides by y, I get this here. And now I'm going to take the integral of both sides. And then I get natural log of y equals 1/2 x squared plus c. Okay, and I could, and we're trying to solve for y, right? So think of this as log base e y 1/2 x squared plus c. And now I'm going to convert this to exponential form. So I'm going to say e to this power 1/2 x squared plus c equals y. Okay, and as we said before, we can say y equals e to the 1/2 x squared, and then times e to the c. And once again, we can just replace this, because this is just a constant, so we can replace that with a. And so I end up with y equals a times e to the 1/2 x squared. Okay, and this is our general solution. Okay, you may want to copy that down. All right, so same thing here. I'm going to multiply both sides by y squared. I'm going to divide, I'm still going to multiply both sides by dx. Okay, so now I'm going to take the integral of both sides. Okay, the antiderivative of y squared is 1/3 y cubed. The antiderivative of 1 is x, and then we have to put the plus c. Okay, and then we're solving for y, so we multiply both sides by 3. I end up with y cubed equals 3x plus c, and then I take the cube root of both sides, and so y equals the cube root of 3x plus c. Okay. Example 23 is explained very clearly by Ms. Castro. So you may want to watch what she did. Here is my work for the same thing if you want to hit pause and check your work. Otherwise, please watch her video. She explains it very well. Okay. There's a picture of her. Ah. Okay. Example 8. Okay. We're going to divide both sides by e to the 2y. And I'm going to multiply both sides by dx. Okay. Now, since this is in the denominator, I'm going to rewrite this as e to the negative 2y and bring it in the numerator. We'll take the integral of both sides. Okay. That's a 2. Okay, so now the antiderivative of this is negative 1/2 e to the negative 2y equals, and the antiderivative of this is 1/3 sine 3x, and then we have the plus c. Okay, so now we're going to multiply both sides by negative 2, and then I have e to the negative 2y equals negative 2/3 sine 3x plus c. And now we're going to convert this to logarithmic form. So, I'm going to say, because we're trying to solve for this power here, right? So I could say natural log of 2/3 sine 3x plus c is equal to negative 2y. Okay, and then we divide both sides by negative 2, and then we get y equals negative 1/2 natural log of negative 2/3 sine 3x plus c. Okay, and then now we're going to find, this is our general solution. And now we want to find our particular solution when x is 0 and y is 0. So let y equals 0 and x equals 0. So then I get 0 equals negative 1/2 natural log of sine of 0. That's going to give me 0, 0 plus c. Okay. So now, if I have 0 equals natural log of c, so think of this as log base e c, right? So if I convert that into exponential, that means I have e to the power of 0 equals c. So that means c has to be equal to 1, because anything to the 0 power is 1. So, the particular solution is y equals negative 1/2 natural log of negative 2/3 sine 3x plus 1. Hit pause if you need to see this a little bit longer. Okay, I'll do one more, and then for the others on this page, I'll just show you the answer. So here I'm going to multiply both sides by dx and multiply both sides by y squared. And I get y squared dy equals 3x dx. Okay, and then I get the integral of y squared dy equals the integral of 3x dx. And then I get 1/3 y cubed equals 3 over 2x squared plus c. Now I'm going to let x equals 0, then we get y equals 1 from this information here. So then I get 1/3 equals 3 over 2 times 0. So that means c equals 1/3. Okay, so now if c is 1/3, let's go back to this equation here, where we have 1/3 y cubed equals 3/2 x squared plus 1/3. I'm just taking this here and plugging in, instead of c, I'm plugging in 1/3. Okay, and now everything is divisible. We're trying to solve for y, right, to get our particular solution. So we multiply everything by 3, and we get y cubed equals 9 over 2x squared plus 1, because I've multiplied everything by 3. And then I take the cube root, and we get y equals the cube root of 9 over 2x squared plus 1. Okay. Let me show you the answers for this one. Hit pause. Okay, and here are the answers for these two. Hit pause. Okay. What's the next one? Okay, example 24 is really important, but let's do 29 first. Okay, so we've got this equation. If we multiply, we divide both sides by p and multiply both sides by dt. Okay, dividing both sides by p, multiplying both sides by dt. Now I'm going to take the integral of both sides. Okay, the antiderivative of 1 over p is natural log of p. The antiderivative of 1/5 is 1/5 t, and then plus c. Okay, now think of natural log as log base e, right? So if we're solving for p, we need to, because we're trying to write an expression in terms of p, right? So I need to convert this to exponential form. So e to the power of 1/5 t plus c equals p. And just like before, we have e to the 1/5 t times e to the c equals p, and we're going to let e to the c equal a. So we have a times e to the 1/5 t equals p, and we let e to the c equal a, right? That's what we did. And Revision Village likes to do it that way. Miss Castro, in her video, she didn't write it this way. It took a little longer. So, but now we know that at time 0, the initial population is 80. So we're going to let t equals 0. Then p equals 80. So using this equation here, I can say 80 equals a times e to the 1/5 times 0. Well, then I get 80 equals a times e to the 0, and anything to the 0 is 1, so that means a equals 80. Okay, so now I can rewrite this equation, but with 80 in place of a. So now I know that p is equal to 80 times e to the 1/5 t. Okay. All right. Question B. Now that we know this is the equation, we can find the salmon population after 10 years. So we've got our equation, but I'm replacing t with 10. Okay. So 1/5 times 10, we're going to get e squared. And then I plug that into my calculator, and I get p is equal to 591 salmon. Okay. So, okay, 24. If two variables are directly proportional, that means the relationship is A times K B. Okay, you wouldn't necessarily know that before doing this problem. Okay, so find the expression of the area covered by mold at T times. So the rate of the mold in a petri dish is directly proportional to the amount of mold present. So the area covered is initially 2 centimeters, and after 2 days it's 9 centimeters. So the change of the area of the mold over time is equal to our directly proportional relationship, which is K. But we're going to do A um, since it's area here. Okay, so now we've got our initial equation. We're going to divide both sides by A and multiply both sides by dt. Okay, and then take the integral of both sides. Okay, and then I get natural log of A equals kt and then plus c. Okay. So now I'm going to convert this to exponential form. Think of this as log base e. A equals kt plus c. So if I convert it to exponential form, it's e to the power of kt plus c equals a. And remember what we did before. We had e to the kt times e to the c equals a. And we've already got the letter a working with us here. So I'm going to use the letter b. Okay, I'm going to let e to the c equal b. Okay, it's some constant. B is a constant. And so now I've got a equals e to the kt times b. And initially, when the time is 0, the area is 2 centimeters squared, right? So we're going to solve for b, and we get so a is 2 equals e to the k, and then t is 0, and b. So anything to the 0 power is 1, so we know that b is going to be equal to 2. Okay, so now I can rewrite the equation as the area is equal to 2, because we're using this equation here, right? So is equal to 2 times e to the kt. Okay. So now we're going to solve for k. So if I'm solving for k, oh, it looks like 4. No, we're solving for k. All right. So we know that when the time is 2, we know that the area equals 9. So I can using this equation, right? We can say 9 equals 2 times e to the k times 2. I divide both sides by 2. I get 4.5 equals e to the k power 2. And then I can take the natural, I can convert this to exponential form. So I get log base e of 4.5 equals 2k. If I'm converting it to exponential form, e to this power gives me the k2 or 2k. So we've got natural log 4.5 equals 2k. So therefore we know k equals natural log of 4.5 over 2. And I can plug that into my calculator. Doot, 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 and I get k equals 0.752. Okay, so my particular solution is equal to a, so the area is equal to 2 times e to the power of 0.752t. And that is my particular solution. Okay. For part B, they want you to find the value of t when the area is 20. Find t when a equals 20. Okay, so I'm going to replace a with 20. And then we're going to solve for t. So we divide both sides by 2. I get 10 equals e to the 0.752t. I can convert this to logarithmic form, and I get e log base e of 10 equals 0.752t. So we've got this is natural log of 10 equals 0.752t, and divide both sides by that decimal. So t equals natural log of 10 divided by 0.752, and then I get t is approximately 3.06 days. Okay, you may need to re-watch this part, and the rest of the handout I will do in a second video.